Okay, hello everybody. This is Victor Sanchez. Welcome to the meeting of the Howard Astronomical League.
Are you sharing your screen yet?
No, thank you. Ooh. Go away, Zoom.
Oh, we can see it up here.
Oh, but I gotta, oh, you see the full screen? Oh, great.
Yeah.
All right, terrific.
We see your whole window, I think, not full screen yet.
Okay. How about now?
Now we've got the slideshow.
Really? Okay, well, we've got the other view.
It has to be
Daniel.
reversed.
Daniel, go ahead.
I just took a picture of the Pegasus and drone, and Cassiopeia emailed me. Do you have that video I can present tonight?
I do. It's in the I have the picture.
I'm sorry.
I got your picture, and your picture is in the presentation.
Thanks.
All right, so if I should do full screen or slideshow. So now you guys are seeing the online, you guys are seeing, okay, that's what you're seeing. All right, so let me change the view to extend. Oh, wait, duplicate these displays. Sorry, everybody. This is new, this live in-person thing. Do you guys see full screen now?
We see full screen now, or I do.
Terrific. Okay, welcome. And Bryan Holler is here, who just showed me his screen too, and he's able to log in, and our speaker was able to do the same. So welcome to our October meeting. We have a pretty good agenda tonight. We'll go through introductions, announcements, star parties and outreach, book of the month, and then our feature speaker I'm very excited about. I got to actually try to contribute on some of his work. And then we'll talk about our regular stuff, which is what's out this month. And we have some very topical stuff. And then, of course, the images. So star parties, there's one coming up. The weather is sketchy. I don't know. I keep hearing good things and bad things, so we'll have to keep an eye out.
It's improving.
So
It's improving,
yeah, it's improving, a little windy maybe, I don't know. So everybody, if you're around, come on out. I'm planning on coming out. It's International Observe the Moon Night, and we have special, well, we always have an activities table, I think, with Arjun and Bob Savoy, but we'll have an extra activities table out this Saturday. So and sunset is around 6:20, so it's not too late for the little ones. So and it won't be too cold. And planets are in good spots. This could be a really good party. Might have a good turnout if the weather looks good. So and as always, keep your eye open for impromptu events. In terms of other outreach, we had a STEM event at HAL last week for the completely clouded out solar eclipse. But we have some club members who were very industrious and traveled either like ad hoc at the last minute or had some plans to go out west. So we have some nice pictures of the eclipse coming up. But we did have some turnout, a Cub Scout troop, where a few Cub Scouts came and did some activities and took a look at the scope. And I think, we'll hope for better weather next time, but we plan to do this again. Maybe not, I guess, next solar eclipse.
April.
It's next April.
April 8th.
April 8th, thank you. Okay, so And then next up is Crystal.
All right, so I have my book of the month, which is The Red Planet. So The Red Planet is a little deceiving because they're like, oh, it's only 144 pages. But I would say it borders beginner friendly to intermediate. So let me grab my notes because I'm a nervous public speaker.
For a teacher.
I know. It's like, it's your job. And I'm like, I get it. So this was published in 2015. I wanted to give a little background on the author, Giles Sparrow. He has a background in astronomy and science communication, and he worked on various popular reference books, including DK's Eyewitness series, as well as their Space Encyclopedia and the Dinosaur Encyclopedia. So if you ever loved those eyewitness books with the diagrams as a kid, this is a guy who worked as an editor and gave some background in that same series. So, you know, he does a great job with the imagery and the explanations are super detailed. So I just said that this book, you know, it gives a lot of imagery, really brings Mars to life. It's not too technical, but I will say that there's parts of it where this is maybe not child friendly. I wouldn't hand this book to like a first grader and say, here's a book on Mars. But it is a good read if you're not familiar with the terminology of major features on the surface, or if you're interested in just knowing the historical context of the missions and the mapping efforts to know more about the surface. And it has a lot of great references to what is interesting about the future of Mars and where our future missions and efforts for like colonization will lead and the obstacles that kind of stand in the way. So I highly recommend it as if you kind of have some context about Mars already, but you're looking for more specific details or are more interested in the history and context of the book. It's fantastic. You know, I won't accidentally violate copyright or anything, but you know, if you pop it open, there's some really great pictures and great little illustrations that are throughout the book. So highly recommend as a great little table, like just a coffee table book, if you're interested in having something about Mars.
Thanks. Nice, pretty glossy photos. Okay, great. So I would like to, without further ado, introduce Bryan Holler. You say it Holler?
Yes.
Bryan is a scientist one at the Space Telescope Science Institute. So, which means I guess you've been there 7 years. Dr. Holler first knew he wanted to be an astronomer when he was in high school. Speaking of Mars, during a close approach of Mars to Earth, entered college a few years later at Maryland and got his astronomy major and his PhD at the University of Colorado, Boulder, in 2016. For the last 7 years, he's worked at the STScI, something like that,
Right.
in Baltimore, and he's been working on solar system support for solar system observations with James Webb, and he likes to study trans-Neptunian objects with what he's talking about today, which are some of the stellar occultations, things you can learn with stellar occultations. So if you want to,
You're gonna need
I need to give you
need to stop sharing.
if I stop sharing. Hi, Dwayne.
This way then.
Thanks, Dwayne.
Awesome, that worked.
Should I stay in the front?
Wherever you feel
The
comfortable.
camera.
Oh, the mic is here, so
Okay.
and here's the camera. So maybe if you sat
Yeah.
here, it would be good.
Okay.
You want me to advance the slides for you?
I got.
No, I
you
get
got it right.
Yeah,
for his
I'm
thing.
here. Or maybe, yeah. I actually feel better talking to people.
Yeah.
So I'll do this. Good.
Great.
All right.
Welcome.
Yeah. Hello. Thank you for the invite. It's a pleasure being here. Always nice coming out and giving some public talks. I apologize. I don't have any swag. I'm
all right.
still learning that part of it. I need to pick up a thick stack of stickers next time I go to the office.
Sorry, can everybody hear Dr. Holler? Anybody?
I can online.
Okay, great. Thank you.
Great. All right, so my name is Bryan Holler. I work at the Space Telescope Science Institute. And this talk is going to be on the stellar occultations. So yeah, small, tiny shadows, big science. Let me see if I can get rid of some of this stuff on my screen. All right. So I'm going to do a little, mix it up a little on how I'm going to talk. Usually, maybe I should introduce myself first. But I have that a few slides from now. You'll see why. It makes sense. But first, let's start out with, what is a stellar occultation? So this is when a foreground solar system object passes in front of a background star, casts a shadow on the Earth, and by observing that shadow at different places, you can piece back together the shape of the object, the size of the object, and learn other things about it, things in its local environment. So if there are other satellite, if it has satellites, or if it has rings or an atmosphere, you can figure this out from this very simple but powerful technique. And this is kind of similar to current events, right? With the eclipse, right? So it's just a different. It's different degrees, right? So you have, if you're looking at a foreground object passing in front of a star that is light years away, that star is either visible or not when the object is passing over top it. It's a point source, so it's gone. An eclipse, on the other hand, right, is when you have, the objects are extended. So you have over time, the light from the star is being blocked out, and then, on the other side of it, you have the light coming back. So it's just, the duration of the event and things like that. So they're very, very similar. And I wanted to ask the group if anybody has been to, have you seen a total solar eclipse before?
Yes.
Okay, that is, for those of you who haven't, I'll put a plug in for, do that before, at some point in your life, right? There's one more coming up next year, as you were saying, in April. I think the closest point to here is probably upstate New York, but I don't really recommend going to upstate New York in April.
Texas.
So yeah, the weather won't be great. So you got to go to the Southwest, I think, for this one. But it is a truly awe-inspiring event, and you can see why they've changed human history if you experience that. But yeah, I went to my first one in 2017 in Wyoming. And just watching, being on a hill in Wyoming and watching the shadow come straight at you is pretty incredible.
Awesome.
So yeah, all right. Now me. All right. So how did I get into astronomy? There's a little bit in the blurb from the beginning, but I don't know if anybody else shares the same story, but I initially became interested in space and astronomy and science probably with 2001: A Space Odyssey, the book. This is because this was around 2001, the year 2001. And I thought, what did people think was going to happen in 2001 all those years ago? And obviously we didn't go to Saturn. But that kind of opened me up to being interested in science in general, the science fiction aspect of things. And a few years after that, there was the closest approach of Mars to the Earth, right? The closest approach in 50,000 years. Happened to go to the library and grabbed a bunch of books on astronomy, and I was hooked at that point. So that was now 20 years ago. Goodness. But I knew at that point that I wanted to be an astronomer. Didn't know exactly what it meant quite yet. But that was where my interest began. And I started, the amateur astronomer track. Right, so actually using telescopes and things like that to look at the sky, whereas most astronomers you talk to probably can't point out a single constellation. But I tried to learn some of that before getting into taking the professional track.
Is that why you agreed to come to the HAL meeting?
Yeah, I noticed that it's
Right.
Yeah, it's appropriate with the HAL 9000. So. And a lot of people usually start off their story, their life begins when undergrad, right? I tried to give a little bit before that, but I went to the University of Maryland for my undergrad as an astronomy major. Did my PhD at the University of Colorado, and out of PhD went to the Space Telescope Science Institute in Baltimore, where now I work on the James Webb Space Telescope, and I carry out my research program on trans-Neptunian objects. So my thesis was on Pluto and Charon and Triton, the spectroscopy of their surfaces, understanding how those have changed over time. And I've tried to expand out from there to other dwarf planets and other TNOs and things like that. What I'll be talking to you about today is something I've recently started working on with other researchers across the country and across the world. That's the stellar occultation campaigns. So one of the first stellar occultation events that was successful for doing something other than giant planet atmospheres was the detection of Uranus's rings. This was back in 1977 by Jim Elliott and his team. And I mentioned that because Jim Elliott was my advisor's advisor. So my grand advisor. I unfortunately was never able to meet him. He passed away before I started working with my advisor in grad school. But it's interesting to see how my advisor did not bring me into stellar occultations in grad school. That was not my research focus. But now I found myself in anyway, kind of continuing the line from my grand advisor, my advisor to me. But yeah, the Uranus rings were detected serendipitously. There's no expectation that they should be there. They actually were using a telescope on an airplane called the Kuiper Airborne Observatory. And by watching the star longer than when it was close to Uranus, they're actually able to detect, I believe, 5 or 6 of different rings of Uranus at this time. And of course, those were followed up later by Voyager, and with recent pictures with the James Webb Space Telescope. You can actually see, in a very short amount of time, you can see the rings of Uranus. Shortly after that, I believe like a decade later, was the discovery of Pluto's atmosphere. So people like to ask me, do you think Pluto should be a planet? And I find that question to be really uninteresting because there's so much else going on with Pluto that what we call it doesn't really matter, right? But Pluto's atmosphere was discovered in the late 80s via stellar occultations. And you can see the light curve there. So if you're watching the star pass behind Pluto, for objects without atmospheres, you just have a drop, flat line, and then a straight back up, right? It's discontinuous. There's no slope. When you have an atmosphere, the star is slowly losing, you're slowly losing light from the star as it passes through the atmosphere and behind the object. So you end up with this curved shape that you see on either side. So
is Pluto a planet?
I think it's better because it is part of a larger population. It is the largest member of a larger population of objects. That's my take. It might not be popular with everybody else that studies Pluto, but
It's not.
I don't think it is now. That's my feeling on it. But yeah, so I believe this was again Jim Elliott discovered the atmosphere of Pluto, and Pluto's atmosphere is actually made of largely the same stuff that ours is, right? Nitrogen. It's mostly nitrogen in Pluto's atmosphere, and then there's some methane and some carbon monoxide as well.
Is there any oxygen? I'm just curious, or just none?
Oxygen, right, is very reactive. So you end up with oxygen in water, in carbon dioxide, carbon monoxide, but no O2 by itself, right? In order to sustain the levels that we have here on Earth, right, you need life. So otherwise it's going to react with everything around it.
Thanks.
Yeah. And this is one of my favorite pictures from New Horizons. I thought I'd put this in here. You can see the topography on Pluto. You can actually see the haze layers. There's haze in the atmosphere as well. So the methane is being processed by radiation and forming ethane and propane and all these other anes, right? These longer chain hydrocarbons, and you get these layers in the atmosphere. And these can actually be detected in, if you're observing fast enough, you can detect these with stellar occultations as well, these different layers. And a little bit of work that I've done recently with monitoring Pluto's atmosphere. So there's other work by studying the occultations over time. You can see how the atmosphere is changing. So it's actually been, the atmospheric pressure has been increasing on Pluto over time, even though it's getting farther from the sun. And we can try and tie that to what's happening on the surface. So with Pluto, there are large reservoirs of ice. But over time, that ice can sublimate into the atmosphere or be transported to other parts of the surface that we can't see. So there's actually predictions that the northern hemisphere of Pluto will be completely, remove all of its ices within the next decade.
Wow.
Be nothing left in the top, the northern hemisphere there.
So, sorry, don't know my Pluto hemispheres very well. What is it? I'm forgetting the names. The Sputnik Planitia. The bigger thing is.
That's along the equator.
Oh, okay. So it's just up above that.
Yep. Sputnik does not disappear. It's such a thick layer of ice that it's always there, and it's at the equator. But the northern hemisphere has less ice, and that could sublimate as the subsolar latitude moves north. So as we approach some northern summer on Pluto, actually remove more of this ice, and that can go into the atmosphere and make the atmosphere thicker. We can detect that through the occultations. And then as Pluto gets farther and farther from the sun, doesn't matter what the angle of the sunlight is, you're getting too cold, right? And you can see from this curve, so all the points there in the top left here, all of these points are from the past. And then over time, they're predicting that the atmosphere is going to decrease significantly as time goes by. Right? It's going to freeze out.
That's water ice.
This is mostly nitrogen and methane. Yep. On Pluto, water ice is a rock.
Okay.
Yeah, it is not in the atmosphere at all. Yeah, it's just too cold. And some of the work that I had done recently was to look at changes of the surface ices over time, and actually finding that some of the ices are increasing their concentrations on the surface. As you lose nitrogen, you're increasing the relative abundance of methane, and we were able to detect this. And so this kind of plays into the story of what's happening to Pluto as time goes by, right? So equinox and perihelion were in 1988 and 1989 respectively, and since then we've been moving towards northern hemisphere summer as Pluto gets farther away. It has very weird seasons, so they're not, on Earth, right? It's every 3 months is a different season, but with Pluto you have very short spring, longer summer, and then much longer fall. So they're not equal lengths of time.
I find it very interesting, though, that data, that it changed that much in just a few years.
Yes.
And it wasn't like you were studying this for your 20 years or 50 years or whatever, that it dramatically changed just in a couple of years being that far from the sun.
Yeah.
And that's amazing to me.
Yeah, the atmosphere changed a lot, and the work that I was talking about that I had done, that was 1 year. We saw changes on the surface within 1 year, which is 1/248th of a Pluto year. Yeah, that's like noticing something changing on the Earth in like a day and a half.
Does the fact that Pluto doesn't follow the plane of the ecliptic and has a highly elliptical orbit, does that have an influence in terms of climate or atmosphere or not?
Yes, on Earth, right, the northern hemisphere summer occurs when the sun's directly overhead at 23.5 degrees north. But on Pluto, this gets to 60 plus degrees. So the tropics on Pluto, it's a very tropical planet. You have
Okay.
there's very little that isn't where the sun won't be overhead at some point during its year. Yeah, so all those things factor in to provide really weird seasons.
Good.
And yeah, we're trying to study it now, almost 100 years since the discovery of Pluto, not even halfway through its orbit yet. So we have a lot to learn still. Another exciting thing in the early 90s, so kind of going through this chronologically, there were these mutual events between Pluto and its largest moon, Charon. So this is when you're looking at it just right so that the moon is passing over Pluto. So Charon's passing in front of Pluto and then behind Pluto. And you can observe these in the same way you would in occultation. Observe it over time, and you can figure out brightness patterns across the surface. So this was actually used in the early 90s to get a first map of Pluto. And you can see it here on the left. This is the earliest map of Pluto, and there's New Horizons. So you can see even that point, you could see the dark band across the equator on Pluto, just from observing, just from doing a light curve, right? Just quick images over time. I can't describe the math involved with it, but somebody did it and was able to come up with this map. You can do mutual events for other systems as well if you know the orientation of the orbit. There are actually some predicted for the system called, this trans-Neptunian system called Monway with the satellite Thorondor. For anybody who really likes the Lord of the Rings, these are some parts of the Lord of the Rings lore. The person who named them was a fan. So, so there were predictions that there would be mutual events for these objects, but they didn't end up happening. We didn't see anything when we were observing, and it turns out that maybe the primary object is really thin. It's like this thin peanut shape because the satellite was not able to cross directly in front of it. You get this weird information out of that.
Is it good or bad that I know who Manwe and Thoron are?
That's up to you.
Congrats on the nerd cred.
So, and yeah, these don't occur very often because you expect to get 2 mutual events for each binary system over the course of its year, but obviously these have hundreds of year-long orbits. So catching one is very difficult, right? To wait for the right time for the alignment to be perfect to observe them. So we missed out on this one because of the peanut, but there are more coming in the future. And getting into kind of the meat here. This is probably, in my mind, the most exciting, or one of the most exciting scientific discoveries, not just in astronomy or planetary science, but in science in the past 10 years, is the discovery of rings around minor bodies. So we're talking about objects that are 200 kilometers across, right? They're too small to be rounded. They're lumpy potatoes, and they have rings. So the first detection was of the Centaur Chariklo. So the Centaurs are the objects that orbit between Jupiter and Neptune. They're escaped from the Kuiper Belt. And this object is about 200 to 300 kilometers in diameter. And rings were detected around this object, and they continue to be detected. They're not just a one-time thing. They're stable around these objects. And one of the funny stories with this one, this was so completely out there. Nobody ever thought this could happen. So when the occultation had been done for this object and they found that there were tiny drops on either side of the body, they didn't know how to interpret it initially. And so you had the group of people sitting around a table trying to figure out what it was. And somebody who hadn't been participating in the conversation came up, looked at what they were talking about and said, it's rings, right? They thought it was jets, like perfect jets coming out of certain spots, but like if you have it all the way around, that's called a ring. So yeah, just completely paradigm changing observation. And then a few years after that, the dwarf planet Haumea. This is one of the larger TNOs. It's a rugby ball shape, and it rotates every 4 hours. This thing is really spinning fast. Rings were found around this object.
So were you able to determine what those rings are made out of?
So there's currently no information about the composition of the rings. So far we can only detect them through stellar occultations.
Okay.
We can't directly image them, and we can't perform spectroscopy on them to determine their composition.
So would that also say, though, that object, although small it is, it has a strong enough gravitational field to have something orbiting around it like that, or is
well, yeah,
got to be holding that ring in place, right? So
yeah, I mean, and Haumea too is a little larger. Haumea is about 1,000 kilometers across. And it has 2 moons that are farther out from the rings. But in order to maintain rings with that kind of weird shape is something that people are still struggling to try and explain, right? It's easier to explain when you have a sphere, but when you have a rugby ball, it's a little more difficult. So that's the challenge. Yeah, it certainly has enough gravity to maintain the rings, but keeping them in stable orbits without having the whole thing crash down on the surface or escape the system is difficult to explain. And another more difficult system is Quaoar. It has 2 rings that are interior to its satellite Waywatt, but the rings themselves are outside of the Roche limit. So the Roche limit is the point where if you have a satellite orbiting within this limit, it'll be broken apart into rings. And if you're orbiting outside that limit, then the material can form into a satellite, right? You don't expect rings outside this limit. But in this case, we see rings outside the limit. It doesn't make a whole lot of sense. How did they get there? How did they maintain? There's still a lot to discover there. And these papers were just published this year. So I was actually part of this event. I helped get some of the data in Hawaii that discovered the second ring. And yeah, we almost didn't get it. The instrument had to be rebooted right before the occultation started. I'm sure you all understand about how things don't always seem to work out when you want them to at the telescope. Yeah, we were able to reboot it with a few minutes to spare, got the event, found the second ring. So that was a lucky event. And then also recently, another Centaur Chiron detected. There are 3 different rings detected around this object. So we're not only are finding more objects with rings, we're finding weirder and weirder situations of rings around these objects. And there's estimations that 20% of minor bodies, not asteroids, but outer solar system minor bodies could have rings. So we just need to make sure we can try and find them.
Is there any thinking on why you would find it in TNOs but not asteroids?
That I don't know. I haven't thought about that much either. In terms of the question about composition before, this idea that it could be water ice, right? So you're not going to have water ice around asteroids. It's going to, right? You don't have solid ice at those distances. But farther away, there's more material to form the rings. But yeah, it's as I said, this is 10 years ago was the first discovery, so there's still a very new field.
Maybe less interactions with it because things more sparsely spaced out there. Maybe less interactions to disturb the formation of the rings.
Yeah, that could be another possibility too.
So I'd never even thought about this, but the DART program, will that thing eventually form a ring? Like the stuff that was.
It depends on the ejection velocity for the material from DART. If it's too fast, right, that stuff's gone. But I think there are some boulders that are sticking around around the object. But yeah, that is a really small object, though.
That's too small.
A few hundred meters or so. These are a little bit bigger, but who knows, right? I think continued observations would be good in that regard. And we've even used the James Webb Space Telescope to perform an occultation. So it's not just ground-based observations. You can, any telescope with the right kind of camera, you can do this. So you can see on the right there, this is Cheroklo. So it's that centaur again, the first one that was found to have rings. See it moving in front of the star, doing a little video there. And one of my favorite stories is how this was, how this observation was performed. So with JBST, you have to set your observations ahead of time, but you can do what's called a target of opportunity. And you can say, I want to observe something, and you can trigger the target of opportunity within a few weeks of the event happening and inject it into the schedule that's already been built. So for this one, the team was looking at different predictions for the event, right? So we see, here the blue line is the star passing behind Cheroklo. There are the two rings, and the black circle is the solid body. We see the stars passing through everything, right? You're going to get the solid body, you can get the rings, all of it. This was in August of last year. And a little update in September. So like a month after that, right? Still on track. A little bit after that, still on track. And then end of September. All right, this event's supposed to happen on the 18th of October. So I think we're ready to go, right? We got a good prediction for the event. It's going to pass behind the object and the rings. But as of course, you know how these things go. You probably know what's going to happen on the next slide. The prediction right after that had the star falling off of the solid body. And then the event itself on the 18th is just off. And here's the final prediction. Final prediction on the left, and then the reconstruction from the event itself on the right. And if you can't see much white between that green line and the solid body, it's because there's really not. It was off by, 130 kilometers.
Wow.
So you could say, oh man, we missed the solid body. But when I look at this, I say, we can predict where an object is going to be with respect to a background star using a telescope on a crazy orbit, 1 million kilometers from Earth, that is every week or 2 weeks is repositioning itself with a little bit of fuel, right? We're able to predict this event happening this well. And here are the results of it. So we only got the rings. Luckily, this object has rings, otherwise we would have got nothing. But you can see both of the rings there, and we're actually seeing the second ring actually appears to be disappearing. It was weaker than it was observed from the ground previously. And we're working on a paper on that right now, so it hasn't been published yet. But yeah, there's something happening with that second ring.
Since I'm determined to be as knowing as possible, I haven't had a question. Sorry.
I like questions.
I'm just curious whether you sort of get different insights from ground-based telescopes versus JWST.
Yes, so that could be another thing that could be going on there. While the second ring looks weaker from James Webb, it's a different wavelength range. From the ground, we're using visible light. James Webb, we're using infrared light. So that could be giving some indication of the size of the particles, for instance. Might not be disappearing, might be a different size particles for that ring in particular. We need another ground-based observation to be sure, to see what's going on there. But yeah, you can get information about that from it. And Cheroklo itself, on the right there is a spectrum showing water ice. So there is a lot of water ice on this object. So that could be what the rings are made of. Yeah, they're bright enough to be contributing a certain amount of flux to the object. But it's not entirely clear what they're made of, or if there are shepherd moonlets in the rings, right? Sort of like with Saturn. Yeah.
But a comparison between a ground-based optical telescope and a radio telescope confirm or tell you different things? because it's not getting absorbed into the, well, it's both getting absorbed in the atmosphere. That wouldn't make a difference because it's here. But
Yeah, with a
just
radio,
longer wavelengths.
yeah, with a radio telescope though, yeah, you're not going to be able to separate the rings from the object
Because the wavelength's too long.
Yeah, and yeah, you could, I guess you could do an occultation with radio telescopes, but the background star is going to be so faint in radio that you're not going to get as good signal noise as you would with visible light.
Got it.
Yeah.
I get it.
And one of the crazier things in my mind is that we can detect topographic features. Not only can we look at shapes of objects, but we can detect topographic features on objects 40 times farther from the sun than we are. And in particular, this object, 2002 MS4, is the largest object in the solar system without a name, right? So this thing doesn't even have a name, but we know it has a canyon on it. So on the left, there's a map showing all the different stations in Europe that obtained chords on this one event for this object back in 2020, August 8th, 2020.
And some of those amateurs?
A lot of them probably are, yes. Yeah, there are not that many university or other professional facilities that we rely a lot on amateur astronomers for that.
Can contribute.
And I'll make sure to talk about that at the end. Yeah. And so for this particular event, you can see how observing all these different chords, you can piece together the shape just by looking at it. Right. You can see this if you look here, there's the shape of the object on the limb, showing this weird deformation detected from the chords themselves. So yeah, very high density on this one. Not all of them are like that, but if you're in the right spot, you're going over the US, you're going over Europe, you're going to get a lot of these at one time. And Arakoth, here's another one with shape. And if you maybe some of you have seen this picture. So this was the second flyby target of New Horizons.
Yeah.
But before the flyby, there was a large effort to try and get the shape and the size of the object from occultations on the ground. So a lot of them, I think they took place in sub-Saharan Africa and South Africa and middle of nowhere, like Patagonia and in Argentina, right?
Yeah, speaking of peanuts, this is actually something I've been curious about for a while. With new directions, what have we learned from Arakoth that's informing our knowledge of Pluto?
Arakoth and Pluto, they're very different, obviously, in terms of size, right? Pluto is 2,000 kilometers in diameter. Arakoth is 10 to 15. Arakoth is a building block of what eventually would have become Pluto if it had been included with other Arakoths into larger objects. And so these, Arakoth and its kin are considered, some of those primitive objects in the solar system, right? They're the remnants that never got incorporated into larger objects. And a lot of those have this double shape, right? The contact binary. So yeah, in that way, it's telling you what's inside Pluto. If you could go beneath the surface.
Right.
And yeah, for the events trying to get the shape and the size of this object, well, yeah, there's the flyby.
That's some quality animation you got going on there.
It's a very PowerPoint. Yeah. And you can see again here, right? You see the shape hidden there in the tracks. And there, I'm going to blink it in and out, right? So there's Arakoth. We got the shape ahead of time, right? And you kind of knew what we were supposed to be seeing. So again, very powerful technique. And this is, again, a 10 to 15 kilometer size object. The smallest object we know of at these distances.
How much time are those lines?
Seconds.
Okay, so if it's rotating, if it's rotating slowly, like it won't distort.
Yeah, so if you have a track across a large part of the Earth, then you could maybe get a little rotation between at one end to the other. But for most of these, they were all very close together spatially on the Earth. And the event itself is very short. A lot of these are a few seconds long. So the path you're seeing there is at most a minute, probably, for a lot of those tracks. Yeah, so talking about short occultations, this was one of the first ones I participated in. I actually went back to the University of Maryland, to the observatory there, and was working with the observatory director to get one of the chords for this one, the chord here. So the purple line for this object. This is the largest. This is Hiaka, the largest satellite of Haumea. It's about 300 to 400 kilometers across, so large enough to be rounded. And there's a prediction in April of 2021 for an occultation in Morocco. Actually got one observatory in Morocco to observe it. And then it went across the continental US. From right around this area up to British Columbia. So it's actually a very large effort to try and get this occultation, because it was the first one predicted for a TNO satellite. Right, so not only do you have to worry about the movement of the object around the sun, you have to worry about the satellite's movement around the object. So it's very hard to predict these. And an effort I led with a colleague from UCF, we were actually able to line up amateurs and university telescopes across the path. And we were the only ones that were able to get it. The path moved farther north than was predicted. And the people that we had lined up were the only ones who ended up getting it. There were a bunch of people, as you can see here, just to the south of it, that didn't record the event. But from that, we were able to get this, and again, like an elongated shape, rugby ball shape for this object, which seems to be the shape for a lot of these smaller objects, right? They're not spheres. They're extended. There was another event that occurred in June this year that went across the American Southwest. It actually occurred at the same time that there was a conference of minor body people in Flagstaff, and the occultation was going over Flagstaff. So we were actually able to get a few people there, brought their telescopes, and they were able to get some chords on the event. But that's still being processed right now. That was for Waywat, the satellite of Quawar.
So I have a question on the shape. So your center picture there makes it look like a little bit of a squashed egg.
Yeah.
So I could imagine what the shape would look like from a two-dimensional perspective, because of the paths, right? So, but I'm having a hard time comprehending how you capture the 3D portion when it's really a 2D pass, right?
Yeah, so you're whenever you're doing these observations, you're seeing the shape projected on the sky for the particular rotation phase that it's at, right? So if you have imagine looking at a football or a rugby ball, right? If you look at it long ways, you get this shape. And if you look at it down this axis, you get a smaller shape. So you have to actually combine this occultation information with a rotation light curve to determine where in its rotation the object was during the occultation. And you can say, okay, well, it was brightest when we observed it for the occultation, which means that you're looking at it this way. Or you can say, oh, it was faintest, so you're looking at it this way. And you can combine that information to get the full 3D shape.
I hear you.
Okay.
I just haven't had time. We'll have to show up at your shop one day and look at how that works.
Sorry, I'm trying.
No, I hear you. It's just to get my head wrapped around it.
Especially since the Earth's flat, so why would you think these things are flat? Right?
Yeah,
Very
sometimes you see it's just a very thin line. Yeah. And the reason why I'm here talking to you today was there is an event on September 28th, so less than a month ago, that also was passing through this area. It was for the TNO called Chaos. The actual name of it is called Chaos. And I reached out to Victor and asked, would you like to use the HALO telescope to observe this event? The predicted track, as you can see here, the blue lines show the track, the prediction, and the stars where we are, roughly. It was not predicted to be over our area, but you reported a positive detection, right? So the track actually moved farther east than the prediction was. And as far as I can tell, I haven't seen all the results for this one yet, still being pieced together, but this is one of the only positives so far. And this is right on the edge. So it's shorter than expected because you're getting, the edge of the object, so the occultation's occurring for a shorter amount of time.
So it's another contact binary?
This could be a contact binary, and that's why we're trying to observe it for this event. And you can see here on the left, right, you're comparing it to Arikoth in terms of size. So if chaos is a contact binary, it is the largest contact binary in the entire solar system.
Wow.
So depending on the different chords that come out of this, trying to be able to piece together information here, right? So these lines are showing previous occultations for the object. We're missing them right here. So are they connected or not? Right? The goal was to try and do that, try and connect in between the objects to see if they're separated or not. There's also the possibility that there's another satellite farther out. So we contacted people all over the continental US to see if they could observe the event. But of course, if there is a satellite, it wouldn't be over the US. It probably would have been over the Atlantic Ocean. But again, I haven't seen the results of this one yet. But yeah, it's great to know there are people in the area that are willing and able to do these events as well. We have a decent number of them that pass over this area each year.
I'm seeing kind of a snowman occurring, recurring theme here with these.
Yes, we're seeing this in a lot of different places now. The suggestion that it talks about how they formed, right? So if you end up with this cloud of pebbles in the solar nebula, and eventually this cloud kind of condenses and you end up with two objects near each other, and then they move in towards each other, and then you get this very slow collision that forms this contact binary. So we think that a lot of objects out there are this shape. There's a lot of effort, through occultations and through light curve analysis to try and figure out how many of them have this shape, and it gives an idea of how these things formed, right? How objects across the solar system formed, putting these building blocks together. So it's a key thing. And yeah, if you feel like there's some deja vu here, it's because there are a lot of them. There should be a lot of these objects out there.
I have a silly question. So just because they make contact with each other, like how do they stick to each other? Like
so
become bound.
Yeah.
So if we look at Arikoth again, right,
just like more material just then start to
you end up with
the
gravitational potential of the object is really strange, right? You end up with the neck of the object being an area where material will fall in. So you end up getting this infilling around the neck where the objects are combined, right? But the idea is that these things came together at human walking speeds, right? So that when you walk out of the room, that's the speed that they're coming together, very, very gentle, just kind of kissing, right? And then they stay together. So if they were smaller, they would have continued moving closer in towards each other, but because you can't go any farther than the size of the objects, so they're essentially orbiting their common center of mass, but not really stuck together, right? You could pull them apart if you had enough energy. It wouldn't be that hard to do, but they're just touching, very smallest bit.
attraction and action.
So I think, okay, and there's one last slide and then some information on getting involved. But in December of this year, December 12th, there's going to be an occultation of the star Betelgeuse by an asteroid. And it's not going to occur. You can't see it from the US, unfortunately. But this will be a naked eye occultation event.
Wow.
So for people in Europe, you could go look at Betelgeuse and then see it wink out and come back.
That's amazing.
And for most of the objects that we do this for, right, the stars are small, far enough away that they're complete point sources, right?
Yeah.
That's what I have here. It's a naked eye occultation question mark eclipse, right? Because the Betelgeuse is large enough that you'll actually have a certain amount of time where the asteroid is beginning to pass in front of it and then fully on the disk and then off, right? So they're going to be able to use this to get information about the brightness distribution of Betelgeuse, right? And the star has been dimming and brightening again lately. It's doing some crazy stuff. So they can actually use this to figure out stuff about this star that's how far away, right?
So the center dot over there, that's near Europe or of Africa there, that one.
Yep.
What does that represent?
That's like the mid time of the event.
Okay.
But the track is shown here. It's showing every few seconds is a different part on the track, right? So it's crossing over Turkey, Italy, Spain, and then.
And what time of night is that?
Let's see. So it says here that's 1 UT. So that is 9 p.m. Eastern time.
So we should do a HAL field trip to Italy.
Yes.
Let's
do that.
Well, we're doing
for a few
daylight
seconds.
savings,
Oh,
so it'll be 8.
Yes, daylight
Daylight
savings. Yep.
savings coming in a few weeks.
Okay.
all right.
Yeah.
So it's a free.
Just so you don't get it wrong.
Yeah. Well, yeah, we can't see. If it looks like you might be able to see it in Miami, maybe.
If it was a Maryland, that'd be cool. That's pretty cool.
Yeah.
So that's something exciting to look out for there.
Are you going out to?
No, I'm not tracking this one. The Europeans have this. The European group where they got 55 chords for the one object to get the canyon on it, right? I think they got this one covered. All right, so yes.
Where's that asteroid though?
It's in the main belt.
Oh, okay. Wow.
Yes, this is a nearer object, but it's going to be passing in front of Betelgeuse. It's going to be a quick event because it's much closer.
Okay.
Is that why it's easier to see by the naked eye? Or is that because of the size of it?
It's because of Betelgeuse. Yeah, Betelgeuse is brighter, so you can see that dip.
Okay.
Yep. So here's my last slide. And just if you're interested in getting involved, like I said before, there are a few events that happen each year that cross over this area. All you need is a telescope and an imager, right? So anything with a fast enough readout time, depending on the length of the occultation. So the chaos occultation was almost 2 minutes long in some places.
I got 30 seconds.
Yeah, and you were on the edge.
Yeah.
So 30 seconds, that's a decent amount of time, but some of the TNF satellites were 4 to 6 seconds long, right? So
I just want you to know that the club has purchased with help from some of the members, including Grace, we've settled on and we bought a new laptop PC that's got a little more horsepower that we will hopefully be able to have shorter frames.
Nice.
Because this presentation is really all about me.
And you're the tallest one in the room.
Look, it's privileges. It happens that a couple of us actually have EV scopes, myself included. And I'm really aware of this. This is an astronomy program we have going on.
Yeah. And with the EV scope, they put out calls for participating in occultations all the time, especially there are a lot of asteroid occultations.
Yeah.
So yeah, those are happening all the time. You set it up. It doesn't take long to set it up, align it, and then you say, I want to observe this occultation event on your phone. Slews to that and takes images at the right time, right cadence, all that.
I've done a couple asteroid occultations, but this is amazing.
Nice.
I just have something to say about the second bullet here, the unistellar EV scope. It is that scope that does not have an eyepiece. and it is all controlled through computer. So there's like, in the astronomy community, I feel like there's a little bit of fear about it.
Yeah.
Like you don't really know what it's doing in there, and it may be giving you fake data. I don't trust it. I don't know.
Yeah, I haven't considered that aspect of it. There are some where you can get an eyepiece on them, but yeah, it's mostly you look on your phone and get pictures that way.
Yeah, any of that eyepiece is electronic, so
yeah,
so it's all right.
Yes.
So I have first of all, this has been amazing. This hands down, this is, start to finish, just flat out fascinating. I have a slightly personal question. What originally interested you about Pluto?
That's an interesting question. So I was always interested in the planets more than anything else. In undergrad, I actually worked on neutron star stuff. Very different field.
Yeah.
I didn't know exactly what I wanted to do in grad school, but I kept my mind open. And the might be a disappointing answer for what you're looking for, but I was having trouble finding an advisor after my first year of grad school. It turned out that the planetary people, especially my person who I ultimately started working with, she was on the New Horizons team. She had money to pay me. So I was able to have a job being a researcher in grad school, working on Pluto. Yep. So that's how I initially got, started working on Pluto and all these other objects.
Right.
There's always the interest there, but having some money to put bread on the table certainly helps with increasing the interest. But yeah, so if you're interested in participating, please do contact me. My email is there. Happy to include you on our email list for events when they come up. And yeah, we'll keep you posted.
How much advance notice do you usually have when there's going to be an event?
Depending on the object, we can have as much as weeks to months in advance. And then we start planning it once we feel more confident about the solution for the shadow. We usually reach out a month to 2 weeks in advance. In your situation, I reached out the day or two in advance because I didn't know that this group existed until that time. So yeah, thank you again for quick work and good. And it's a 6-inch telescope, right?
Yeah.
Yeah, so it's very, it's definitely in the size range that we're looking for a lot of these events, where the stars are bright enough to do this with a backyard scope.
Yeah. Well, we got any questions?
When a event is predicted, I would assume it's just a random 17th, 18th magnitude star or so for these distant objects. How much investigation is done about the star? I mean, do you care whether it's as a disk or whether it's binary, when stuff like that confuse your data?
So yes, so almost all of these predictions are made using the Gaia catalog. Right. So it's the Gaia is an ESA space telescope that is obtaining really high precision positions of all the stars in the sky. So most of these stars just have like a 20-digit number for a name. There's not a whole lot else known about them. Like, are they binary or not? We don't necessarily know that going into it. It's harder to tell. But yeah, if you have two stars that it's passing in front of, you end up with a really weird signal as the object passes in front of one star and then the other, for instance. Or you end up getting weird results because in one part of the US, you're getting one star occulted, and in another part, you're getting another one. And you're trying to piece that together. You're like, well, you can't have a rectangle.
Right. And the star doesn't disappear.
Yeah. So yeah, after the fact, if things look weird, we'll go back after the fact and observe the star itself to get more information to try and disentangle what's going on.
But not much before.
Not as much before. For a lot of these events, which the predictions aren't good that far in advance. So
hey, before we're done, everybody, here in the room we don't have the ability to see the chat. So if somebody put a question in the chat, maybe you just want to unmute yourself and ask the question.
There was another question.
Yeah, so what are, apologies if you already explained this, but what are observers recording? Are they recording a video of the event or is there a light window? Like, what are you?
Yeah, it's essentially a video.
I can answer. Just taking frames as fast as you can that are bright, that have enough signal and noise to capture the background star.
So it's an image.
It's an image, and then another image, and another image, and another image.
Okay.
And in my case, I was taking 5-second exposures because that's what I needed for that background star to look decent in a 6-inch scope.
Right.
Did I answer that okay?
Oh yeah. It's a depending on what you call it, a video, right? It's a so whatever frequency you're doing it at, could be a slow video with frames every so often, but yeah, the best occultations are done with really fast readouts. You get high time precision. But of course you have to balance that with the brightness of the star. So the shorter you go, the noisier it becomes. But if you have a really bright star, you can go really fast and really pin down the size.
Thank you.
There are a couple of questions online.
Yeah, go for it.
Go ahead, Steve.
Oh, yeah, thank you. Around 1965, 1966, I was part of a team led by Tom Van Flandern and David Dunham that were observing grazing occultations of the moon. And we would get a group of amateurs to go out and set up their telescopes in a line along where the graze was predicted to be seen. The best sites that we found to do this were along the railroad tracks. And so we would have maybe 10 or 20 telescopes set up over quite a length along the railroad track. Tom Van Flandern was in charge of predicting where the occultation would be seen. Peter Espenshade was in charge of the railroad timetables to make sure we weren't going to get run over. So it was kind of an exciting experiment, whether we really believed Peter or not.
Nice. So you did a picket fence along the railroad track.
Yep. Yep.
So I actually have a question. The observations you did with the James Webb Space Telescope, what observation mode and instrument were you using?
So for that one, we used the NearCam instrument. That's the near infrared imager.
Okay.
And we used it in time series mode, using a very small subarray, so 64 by 64 pixel subarray that could be read out in a fraction of a second.
Okay. Okay. Thanks.
Yeah, with no dead time in between, essentially, and we got, I don't know, 15,000 images over about an hour and a half in order to make this video.
We're not seeing the screen anymore.
Oh, never mind. Don't worry. Okay. Okay. Yeah.
We're looking at the screen. Is that you, Arjun?
Hi, this is Shakila. I have a quick question. Is there any specific camera we have to use to observe the occultation? Because when we went for the conference, the occultation method, they said instead of ZWO, they said some other camera we should use. Is there any specific camera for that?
So I don't have a suggestion for a specific camera, but the best option is one that has a faster readout. So you don't want, if you're, what we suggest when we reach out to people is, to make sure that the time for each sample is at least as long as the readout. So if it takes your camera 5 seconds to read out, we suggest a 5-second readout or a 5-second image, so that there's less of a chance of missing when the object passes over the star, or like when the limb passes in front of the star, and then when it passes over again, right? Ingress and egress. We don't want to miss that part of it. So we suggest longer images then. But if your camera reads out really quickly, you can do really quick readouts, and it's less of an issue.
So it sounds like, maybe an overgeneralization, that a planetary camera would probably be preferable to a deep sky object camera for this application.
Yes, or small video camera, that kind of, we make use of video data as well. So yeah, anything that can read quickly is ideal. Yep.
Wayne, you still have your hand raised. You got another one?
Yeah, I just wanted to point out that you also need a reasonably accurate time source. You don't want to
Yes.
be minutes off on your time, on your clock.
Yes, yeah, tying to I can't remember I unfortunately can't remember what they're called right now, but yeah, tying to sources online. I believe there's some sources to do that.
NTP.
Yes, yes.
That's actually the first thing I did when I started that night was our computer is not online. So I started a Wi-Fi hotspot so that I could get online and get the right time.
Nice.
Does anybody else have any other questions? Well, if not, then I think we should give a really have to.
Thanks. Yeah, thank you for the opportunity to come talk. This has been fun.
So with that, we'll move back into the regular part of the meeting. And you guys seeing the charts online?
Yes.
Okay, so now let's move on to our what's out this month. And Phil is up first with solar.
Okay, so very interesting. Sorry, so I always put the credits up there where I pull this stuff from. So you could go back, or I could send out to the club. I could send the link to the entire articles that are coming up here. But there's two things I'm covering today. This first one is where it says ancient solar storm captured in 14,000-year-old tree rings, and in 1859 it was the Carrington event, I believe it was called, which was the giant solar storm that most people didn't know what was going on at the time, and it was blowing out telegraph stations around the country, caused all kinds of havoc and everything else like that. And by looking back at how the molecules, like it says over here, interacted with the atmosphere, it had an effect in the rings and trees. And they could measure the size of that storm. As scientists do, they figure all this stuff out, just like our guest speaker was figuring everything out from just little light curves and things like that, and what that means. And so in looking at these very, very old trees in Sussex, England, that they were able to look back and using, the carbon dating and everything else they're doing, that there was a massive storm that was just way, way bigger. It says, what was this? There's a stat in here. What was it? Fortunately, my printer wasn't working. I didn't print out the whole article there. I was going to read from my notes, which I couldn't grab out. But nevertheless, it was just magnitudes bigger than this other one. And it was really, really cool. So that was Victor saying, time to move on, Phil. He changed the slide.
No. I was trying to get this.
Okay.
It was being blocked.
Yeah, okay. So
10 times more powerful.
Yeah, so 10 times. Okay, great. Oh, there we go. Yeah, they're right. 10 times more powerful than any recorded in history. So this is a really cool thing that they could look back over 14,000 years ago and see inside these trees that were around then that there was this giant solar storm that took place. I just find this, and that goes back to, when I used to do these meetings all the time, I was always looking for things way back in the future and stuff like that, or way back in the past rather, as well as predicting for the future. But this was really, really interesting. So now
absolutely, that was awesome. That was so interesting.
Yeah. So as I said, I've got these articles at home, and I can just email them out with all the information that explain this thing. But it's pretty cool. There's so
Victor?
Yeah.
Or Phil?
Yeah.
What kind of a scientist did this? Was it biologist? Was it solar physicist? Was it?
I don't know the answer to that question. And I tell you, it could have been in the article, but it's probably in the study that it was released from, like Nature Mag or whatever. So I'll have to go back and look. But I'll forward this out to everybody, and then it'll have the source. But that's a really good question, and I didn't even think to look at it, but I will in the future. So if you want to go to the next slide. So here's the other thing. So the Parker Solar Probe never ceases to amaze me. The fact that it just survives is amazing all in itself, and that people figured out how to build this thing. So I'm always doing something on the Parker Solar Probe, but this one is on how fast it's moving. And you could see that it was moving at 394,000 miles per hour as it was passing by the sun. And now, and let's see, it says there's gonna be another pass coming up in the 2024-2025 flyby, where it's going to get a gravity boost from Venus, and it's going to travel at over 430,000 miles per hour. So, and it's traveling through the sun's corona as it's doing this. And so you kind of got to think about, when we think about space, we think about just being open and like no debris in the way, nothing tearing through things. Once in a while, the space station gets hit by a micrometeorite or something. We worry about the astronauts going to the moon and stuff because there's no atmosphere for it to burn up in. It can hit somebody. But when you think about this man-made object flying through the corona with the materials that are there, just being ejected from the sun, the solar wind, all that other stuff, that this thing survives at that kind of rate of speed, let alone even if it was standing still, survives. It's just amazing to me. I don't know if anybody is on the call here is fascinated by this as I am, but at that particular speed for what it was on August 21st, you could see that if it was here on Earth in an airplane, you could travel from New York to London in 3.2 seconds. That's awesome. That doesn't even give you time to get a Coke and a little bag of peanuts. So strap yourself in, and when you come back after passing out and having your G-forces crush you into a little bug, you'll be all set. And at that, I will move it on to our next presenter. Thank you very much.
Thank you, Phil. Next is the shallow sky. Jim, did you make it? Were you able to break free? Are you on?
Asking, have you considered it for your
I don't think Jim is going to be able to make it, so I'm just going to go through his slides. I'm not as dynamic, and they're not my slides, so I'm just going to kind of go through them. So, basically, in the the solar system right now, Mercury's not looking too good. Venus is good pre-dawn, at its biggest altitude for this apparition. And then I guess when he says altitude, I think he means like the separation, like the separation from, say again?
Elongation.
Yeah, thanks. And then this one I'm excited about. I think most of us are excited about Jupiter reaching opposition. It's going to get pretty big, and it's way higher in the sky than it was last year. And even next year it'll be even higher still. But I'm looking forward to some of the things our club members do with Jupiter this year. And Saturn's still good. So Jim is suggesting that you take your telescope out on Halloween and invite people to look through your scope as a sidewalk astronomer. I don't know if I would do that. I don't want any kids throwing toilet paper or eggs at my setup. But yeah.
Don't forget the citizen science on Jupiter.
Yeah. So should I click on this? Let's click on it.
And the weather will be great because I'm going to be out of town. So you guys, clear skies, you're going to love it.
Thank you, Phil. Are you guys seeing the screen, or are you still seeing the PowerPoint?
We see the sky telescope.
No. Yeah,
I see the PowerPoint, but that's okay. I just wanted you to mention it. I'm not going to necessarily go, but
yeah. So there's a link. Whoops, what did I do? I did something bad. So there's an article linked here from Sky and Telescope, and this when this thing gets turned into a PDF file, will that hyperlink go away?
Possibly, no.
I'm not sure if that will be there, but we'll post this online. If anybody wants it and they can't find it, we'll have to ask Ken if the hyperlinks are
People can go
retained.
to Space and Telescope and look for it.
Sky.
Or just go to Sky and Telescope, yeah.
Yeah, usually when you save as PDF, it retains the hyperlink for like Office Docs.
Okay, so hopefully it'll do that. And then Uranus is going to reach opposition on the 13th. And if you want to see a little blue thing, you can look at, and for a challenge, try to see its moon. Maybe Ken, you can do that with your telescope. I'll try. Ken's got the biggest telescope and the smallest car in the club.
He's a inoculation into himself.
Yeah.
Okay. Other things that are happening in the shallow sky, we got Halley's Comet's dust trail in the form of the Oranids, and they're coming up this weekend. Let's see, 20 meteors per hour, and early Sunday morning, so late Saturday night. Keep an eye open. If we're still out at the observatory, we'll try to catch some. So, or does he mean Sunday? It's Monday. I don't know. There'll be some even on Saturday night. We'll keep an eye out for those. The other thing is Jupiter at opposition. So this is what Jim can see in his scope. The big red spot, the great red spot. There'll be some transits, eclipse, and occultations. The fun stuff on the belts, and then the festoons. Where is it? Oh yeah, and then the south belt, and then these festoons should be good to see on this particular apparition. So these are things you can look for in your own scopes, or I'm sure we'll see some nice photos at the next month's meeting. And then also we got a animation of transit that will be happening oh boy, can I go back? I guess 10:20 at 8:30 p.m. and 11:06 at 7:22 p.m. There will be a Saturn transit. Boy, I wish Jim was here. He can speak to this so much more eloquently.
I think those are probably actually eclipses. I think Tethys is moving through Saturn's shadow.
Okay, thank you. And then maybe this is the transit. Yeah, there we go. So I think he means this evening, tonight. So I don't know if it's clear out right now, but if anybody's up if anybody can't sleep tonight, break out your telescope and look for Io and Ganymede. Okay, so let's move on to Wayne.
Okay, so can you hear me?
Yes, sir.
Okay, so for What's Up in Space, I decided to report on the OSIRIS-REx sample return. OSIRIS-REx was or is a satellite that we sent out to the asteroid Bennu, which is a main belt, which is a near-Earth asteroid, actually, excuse me. It was launched in September of 2016 and arrived at Bennu in early December of 2018. And almost a year or 2 years later, they collected a sample of material from the surface. And you can see on the upper right side, the picture there that shows the sample nearing contact, I believe, with the surface of the asteroid. It was only in contact for just a couple of seconds. As soon as it touched, they blew out some nitrogen gas to stir up the material to hope they got a little bit into their sample collector. And they did. And so it's hung around Bennu for another year or 6 or 8 months, sorry, and left Bennu on May 10th, 2021. And the sample was returned to Earth just recently in September 24th, almost 7 years after the launch of the spacecraft. So the sample is actually the lower picture there. That's the sample capsule. So the little, in the upper picture, the little round head part of the thing touching the surface was actually placed inside of the sample container below, and they actually broke off the arm that the sample collector was on. They actually had to sever the arm so they could close the sample capsule in order to get it down to the earth. I thought that was kind of an interesting technique. But so the sample capsule came down, as you can see, it's sitting on the desert floor in Utah. But the spacecraft itself was repositioned, retargeted to go to the asteroid Apophis, which it'll reach in April of 2029. So they're going to get double duty out of the spacecraft part. There won't be any sample from Apophis, but they can use their other instruments to observe the asteroid. So they collected, they believe, approximately a half a pound or 225 grams of rock and dust in that sample container, and their requirement for the mission to be a success was 2 ounces. So they greatly exceeded their mission requirements. Next slide.
Hey, Wayne, before you move on, going back real quick.
Okay.
I have a question. It's more, maybe it's more of an opinion I'm asking for. So when I read, over and over again that the scientists were so surprised about what they found in there, that they found carbon and oxygen. And I'm saying, I can't believe that that would surprise them. If I was to pick anything from my lack of years in the university on this topic, I would say there was going to be carbon and oxygen. So is this just a really poor reporting, or is there something in anybody's opinion or knowledge that there should be a surprise that there was carbon and oxygen?
I can't believe they were surprised by the carbon because it was a carbonaceous. It's a carbonaceous asteroid. So I suspect maybe some difficulties with the reporting. I think they also found water, and I think that maybe is a little bit surprising.
But yeah.
Okay. And so by collecting this sample, finding out what it's made of, basically, and actually getting to test the materials, it'll help us understand how the solar system, and therefore the Earth, was formed, and perhaps even how Earth got its water, since, like I say, they found water on the asteroid, apparently. And these are very preliminary results. I think they're still unpacking the sample, so they don't even know what all they have. It'll also help us learn how life started in the early solar system by the carbon molecules, and if there's any complex carbon molecules on the asteroid, and also water. And then finally, they're going to learn something about how Bennu is constructed and some of its material properties. You remember the DART asteroid impact, everybody was surprised by how much material it was because it wasn't quite made up like they thought it was. So it's going to be important to do that, to learn that, because Bennu is estimated to have a 1 in 1,700 chance of impacting Earth in 2182. And its diameter is about 1,600 feet. So it's not a small object. Well, in solar system standards it is, but in terms of having things crash into the Earth that we live on, it's not a small object. It would definitely wipe out a city if it impacted in a city. More likely, of course, it's going to land in the ocean, which is perhaps worse, because if it produces a tsunami, it could wipe out all kinds of stuff along the coastlines.
Gosh, Wayne, aren't you Mr. Sunshine?
Well, but that's why getting the samples are important. Now we can learn more about what the asteroid is made of, how it might react, and what we might do if we find out we have to do something to stop it from that impact. So yeah, so anyway, that's what I wanted to talk about today.
Cool. I wonder if the mission planners had OSIRIS-REx nudge it like a little bit in the direction that would lessen the probabilities.
Or increase them.
Yeah, maybe not. Depending on how you feel about humans.
I'm pretty sure they didn't know what the probabilities were at the time. So.
Yeah.
Did anybody watch Psyche launch?
Yes, I did.
Psyche launched on, I don't know, a couple days ago. watched
Yeah,
it.
yeah, about a week ago, roughly. Yeah.
Yeah,
Huh.
it was really cool.
That was on a Falcon Heavy.
Yeah, which came back down. It like re-landed back on Earth.
Yeah.
Yeah.
It's going to another asteroid.
Okay, cool.
Psyche.
Yeah.
Thought it was cool. It's going to an asteroid called Psyche, right?
Yeah.
Yes.
That's why it's called the Psyche
Yeah.
mission. Yeah.
Okay, well, thank you for that, Wayne, and Jim for supplying the slides, and Phil. Jim's not here, he had a conflict, but I was amazed that he had got us the slides because he was out west and for the eclipse, and he flew back late, and had to, he put these together late yesterday evening. So thank Jim for those shallow sky slides. Okay, and now, without further ado, let's go into some members' Astro Images. This is James Willingham. I'm not even going to ask because I know he doesn't come on. Are you don't happen to be on? Do you, James? Never. We can't see the way I've got it set up. We're not seeing the people view. We're just seeing the slides. Yeah, so
he's not
on. Anyways, James had if you were reading the HAL email distribution list, James had a pretty good story about how he drove 8 hours and then drove another hour at the last second, set up and got these images. And I think that's pretty impressive. Got the start, middle, and the end of the partial eclipse from somewhere in South Carolina. And then this is Jim's photo. I really wish I knew how to make this bar go away. I think you do more.
End? No, not end.
I put in the intros.
Oh, thank you. Thank you very much.
I use Zoom one.
Yeah, so Jim made it out to Albuquerque and got a very beautiful picture here, including something which I have no idea what it's all about. Something that he calls Bailey's beads.
So Bailey's beads are the craters in the mountains at the limb of the moon there. When the sun shines through there, it gives us beading. The problem is this projector is such low quality that you can't see it, but you can probably see it on the computer screen better.
I can see
it doesn't show up here at all.
Yeah. So
but so when you in a total eclipse, Bailey's beads are spectacular.
Yeah, you can see them on my screen.
Yeah.
So yeah, there's this. That's very interesting. Thanks for sharing that. I didn't know what they were. That makes a lot of sense too. That's pretty cool. So he had to catch it at just exactly the right.
Yeah, because of this type of eclipse, right?
Wow. And that's really cool. That's extra cool. And then Travis Totten, are you on? This is the Clam Nebula, which I had never even heard of. I don't know anything about this or where it is, but it's a beautiful shot.
Yeah. What's it called? The Clam Nebula?
The Clam Nebula. There's an STScI number, and I don't know what it is, or an SAO number or something. But yeah, it's a gorgeous shot. I don't know how many hours or what scope or anything.
It looks, I can see it because it looks like a giant clam.
It sure does.
Use the shell, use the mouth of the clam.
You don't have to use too much imagination on this one to name it. Although sometimes people name things well before like the caliber of the instruments and the quality of the images come out. So who knows what it looked like when they first named it.
I mean, there's obviously a pearl right in the middle.
Oh, the pearl. Yeah, there you go. Awesome. Thanks, Dwayne.
See, the guy with the best drugs picks that out.
You're on a roll. All right, Ken, we have Ken here with us at the Nature Center. You want to talk about this a little? Or?
Sure. It's the Crescent Nebula. That star in the middle is a Wolf-Rayet star. So it's shed its outer layers, and then it became very bright because it's a different equilibrium. And so that ultraviolet and X-ray light that's leaving there is exciting the gas that it has shed, and that's what you see. Just blue is oxygen, red is hydrogen. And it's called the crescent because visually you can see that little crescent to the right, the bright part, exactly.
Yeah,
The rest of it you can't really see visually.
that was an awesome photo.
Yeah, dude, that's spectacular.
Thanks.
Yeah, this you know, on our Discord group, this was voted picture of the month last month.
Yeah.
So, well, that's just amazing. I always think this thing looks like kind of like a brain.
I do too.
But,
I totally do.
This is another one where it was named well before the, you know. Anyways,
So that clamshell is in Cygnus, 22,000 light years away.
Yeah.
It's got a number of SH2-119.
yeah, okay. I think he said that. Daniel, this is your photo.
Right. I took this picture. When did I take this? I took this back October 8th. I think I took it around 10:04 at night, and I got a really good picture of the peg of Cassiopeia, which is on the left side, and Perseus is under it, and then I got Pegasus and the Andromeda. I really managed to get it all in one whole picture. The picture I thought turned out really good. That's Cassiopeia.
This is Cassiopeia.
Yes.
This is the big square.
Yes. And the Andromeda is right. And that's Perseus.
Yeah, awesome. Very nice.
That's pretty cool.
Great job. Great job.
Thanks for sharing. Is Joseph on the phone? I mean, on the Zoom call, Joe Novatka? I think this is a shoot, he told me in the email, I forgot. It's an asteroid that I'm not sure that I can say. I'm not an asteroid, it's a comet.
Right.
But I'm not sure I can say anything about the photo. He did send me some details, but it's pretty green, and I don't know if this is one that's coming or it's still far away and it's on its way here. I don't know, but it's kind of a cool shot. And then we have Ken again.
Yeah, this isn't a pretty shot, but I was excited about it. It's Helene. It's the moon of Saturn. It was the first Trojan moon discovered because it shares the orbit with Dione. I've been trying to photograph it for 2 years because it's like 18th magnitude and close to Saturn.
So what we're looking at is this right here,
right
between the two little dashes.
And you can see it's moving with Saturn, and the field star is staying put. So it really is it, and not just a random field star.
Cool, man.
Yeah.
What's the big thing?
The big thing is Saturn overexposed.
Oh,
Yeah,
okay.
that's so
that's
cool.
where all the moons are.
Yeah, and all the moons are going with it. And Helene's there. I was happy.
Excellent.
So you were just guiding on a star in the background and you took a few.
Right. They're just actually they're stacks of 30-second exposures, and they're like an hour apart, give or take.
Wow.
Yeah, it's amazing you were able to get it with Saturn being so bright.
Yeah, I've really looked all over the internet. I don't think anyone else has imaged it. I haven't, when I search amateur shots of Helene, nothing comes up, just the Cassini images.
Awesome. So this is with your big SCT?
Yeah, with the 14-inch, yeah.
Wow, awesome. And then Steve, Stephen Gauss, are you on?
Yes. Yeah, this was, I had a lot of trouble with clouds this month. Probably, I assume the rest of you did too, but it seemed like we had quite a few really nice clear nights, and then the clouds would come in around 10 o'clock. So I was kind of limited in what I could get, but this was the transit of Europa across Jupiter. You can see the shadow just moving off the edge there. And
is that Europa on the left side?
Yeah, the moon you can pick out because some of the bands on Jupiter are dark enough. On with Saturn and Tethys, it's really tough because Saturn is so nondescript and Tethys is bright against the bright Saturn. But on Jupiter, you have a chance of seeing the moon against the dark bands. And you can see its shadow moving off.
And what's going on the right here?
Okay, so that's 12P Pons Brooks, the comet that had a major outburst back, the beginning of October, and you can see in the top left slide, you can see the two horns that formed from the from the gas and dust being blown off the surface. But it appears to me to have gotten considerably fainter. The lower left-hand image was through clouds, which is why it's not really great. But it looks to me like it's faded by about at least 2 magnitudes since that time. It's in the northwest, and you can capture it, but right now it is just, it's looks like it's dispersed somewhat, the material that was blown off. And I don't know whether that's the comet that you were showing in the earlier picture or not.
Is this guy ingress or is he on his way out?
What's that?
Do you know if this guy is going to get any better?
Yeah, oh yeah, it's going around the sun, and when it comes out the other side, it supposedly will be much brighter, but of course that's just same as the weather forecast. It's 50-50 whether it will or it won't.
Yeah.
And this is the second outburst this year. It had another one a few months ago.
Right. But that one, I don't think it was in any position for me to see it. I don't remember.
Yeah.
But that 7 October one, it was pretty bright. These are all the same exposure, all 45-second exposures with my 14-inch.
Nice. Thanks. And then we're in. This is the animation section of the briefing, and this is another Jim Tomney. So this is Jupiter, and it's showing Io moving into the shadow and being eclipsed.
You can see it half. Yeah, like a half Io.
Can you see Io's down here in the left corner?
Yeah,
and it's just kind of, yeah, it's almost like a crescent Io.
A crescent Io.
Yeah.
Ooh.
That's just an amazing thing. I don't know where he took this from. October 5th, I think he was here. So yeah, this is with his bigger scope. I think he must have taken this from here. Anyways, and then we have James Willingham again with his awesome planetary shots. These were actually from a couple of them were from last month, and I didn't get them into he sent them to me a little too late. I didn't get them in the last month, so I just dropped them in here. Here's some nice shots of Jupiter.
If anybody ever has a chance to get out with James, when you watch him do this, he is so relaxed and so casual, and it's unbelievable. And he comes out with these spectacular shots.
So that's it. That's all we have for our HAL meeting this week. So I thank you all for coming. I'm going to stop the recording. Thank you guys for coming online, and thank you guys for coming here to it was super fun again, like it always is. And thanks once again to our speaker, Bryan, who really cool presentation. So I'm going to stop the recording.
Oh, you just turned off the video. There you go.
Yeah.
Oh.
No, I need to do some.
Yeah, I'm an electrical.
Right down. There you go.
Yeah, no.